Okay, students, let's come to now question number 6. It says solve this system of equation. So how can we solve this kind of equation? Let's see. So the solution goes like this. Dx over dt is 20y. So let's apply second derivative with respect to t again. So the second derivative of x with respect to t goes to be 20 dy over dt. So having this into account, the second derivative of x with respect to t now turns to be 20 into, because dy over dt is known, here it is, it's already given here, dy over dt is y plus x. So when I put here dy over dt, dy plus x in place of dy over dt, 20 into y plus x can come. So this is 20y plus 20x. And next from this, dx over dt, and look, I want to change this to one variable. Now I'm having x, here I'm having x, but I need to change this y to x. So to do that, I have been given that dx over dt is 20y. So from this I can know what y is. Y is going to be, just divide the whole by 20, 1 over 20 dx over dt. So we can directly use this expression in place of y here. So this turns to be d squared dx over dt squared is equal to 20 into, now look students, in place of y I can use 1 over 20 dx over dt plus 20x. This 20x comes, now 20 can be cancelled by 20, and then I can have, you see this expression moving the right expression to the left, I can have this. So this basically is second order differential equation with constant coefficients. So I can solve this by using characteristic equation approach. So the solution can be obtained as you see. The characteristic equation for that will be m squared minus m minus 20 equals 0. So we need to think of two numbers where their sum can be negative 1 and the product negative 20. The numbers are clearly negative 5 and 4. So this can be factored as you see as m minus 5 into m plus 4. So the values of m are 5 and minus 4. Therefore clearly x of t is now known. C1 is a power of 5t plus C2 is a power of minus 4t. Our intention is to solve the system, and the system is said to be solved if we know x and y. X is already obtained, but we didn't determine y. So in order to know what y is, let's use from the obtained expression. We've said that dx over dt is 20y, so y is going to be 1 over 20 dx over dt. But we knew what dx is, we knew what x is. So in order to know what dx over dt, let's derive this with respect to t and multiply by 1 over 20, then y can come. Thus y is going to be this one, student. Look, dx by dt is 5 times c1 is a power of 5t. This minus 4 comes down, and minus 4c2 is a power of minus 40. 1 over 20 is out, so we can have this. So let's multiply each of them by 1 over 20. So 5 divided by 20 makes 1 over 4. Minus 4 divided by 20 makes minus 1 over 5. So now y is determined. Thus x of t, as we obtained before, is c1 is a power of 5t plus c2 is a power of minus 4t. And y of t is now 1 over 4. c1 is a power of 5t minus 1 over 5. c2 is a power of minus 40. So the system is now solved. Our intention was to determine x and y. Here we got them in terms of the dependent variable t. Next from this, what comes is question number 7, the last one. It says use undetermined coefficient to solve this one. Students, this is basically a non-homogeneous second order differential equation with constant coefficients. So first we have to find the homogeneous solution. Next we will determine the particular solution. Then after we will combine the two in order to find the general solution. This is a procedure we need to follow. So let's now directly go to solution technique. So let's first find the homogeneous solution here. The homogeneous solution is obtained making 3x squared 0. So we are left with this. So as usual, we need to find the characteristic equation. It will be m squared plus 5m plus 6 equals 0. So think of two numbers again where their sum can be positive 5 and product 6. The numbers are 3 and 2, as you know. So this can be factored as m plus 3 into m plus 2 equals 0. And from this, your m is minus 3 and m is minus 2. So the homogeneous solution will be c1 is a power of minus 3x plus c2 is a power of minus 2x. So now we are left with a particular solution. So in order to determine the particular solution using this undetermined coefficient method, we have to observe the expression to the right of the left expression, which actually is 3x squared, so it's a quadratic one. So we have to consider our yp to be a quadratic expression. So in this case, yp is ax squared plus bx plus c. Now the coefficients here are undetermined. A, B, C are undetermined. So it's up to us to determine these coefficients to know what yp is going to be, so that we can take yp together with yh as the final output for the general solution. So in order to do that, take yp to be this expression. So we need to derive yp prime, yp, and we will get yp prime, and that is 2ax plus b. And further derivative of this makes 2a. So we are saying that yp is a particular solution. So we need to substitute these values, the obtained values, in our differential equation and try to match the coefficients in such a way that they can be solved. So after substitution, what comes next is this one. This was the differential equation we are having. Basically, okay, make this to be 3x squared, students. This is not 0, but it's already corrected here. So make this 0 to be 3x squared. So the second derivative of with respect to x is already done. Here it is. The 5 times the first derivative is already obtained, 2x plus b, and 6 times the expression yp as it is comes. And this must make 3x squared. Please make this to be 3x squared. So you see, in doing this, what comes next is these systems of equation. Look here, we are having 3x squared. So let's now see the equivalent like term for 3x squared from the left side. Here we are having 6ax squared. So for this to be the same, necessarily 6a must be 3, because we are having x squared expression here alone. So this 6ax squared must agree with 3x squared. Hence 6a must be 3. What else? The coefficient of x. If you observe the coefficient of x, here we are having 5 times 2, 10a, or else 6 times b here. So that these two must be 0, because we don't have a coefficient of x here. We don't have a coefficient of x here, means this is plus 0x. So we have to adjust that with 0. Next constants are appearing. Look, 2a is one constant, and 5 times b is another constant, 6 times c is another constant. So these three constants must add up to make 0, because we don't have constant here too. We don't have constant here too means this is plus 0. So clearly one can obtain that, you see, a is 1 over 2 from this one. 6a equals 3. A is 1 over 2. Once you obtain a to be 1 over 2, you simply substitute that 1 over 2 in place of a in the second one, and you will get 5. And moving that 5 to the right and dividing by 6 becomes minus 5 over 6. Once you determine these two values, a and b, c can easily be obtained. Simply substitute the obtained a and b values in the third equation and determine c. C is finally obtained to be 19 over 36. Now we have determined the undetermined coefficients. Basically, the method is said to be undetermined coefficients because we are expected to determine the undetermined coefficients, as you see here, like ABC. So the particular solution now is obtained. It was given at the beginning as ax squared plus bx plus c. So we knew a, b, and c, so directly use them as they are. 1 over 2x squared minus 5 over 6x plus 19 over 36. So what comes next is, you see, combining yh and yp as a general solution. So your YH, as we know, is the homogeneous one, the obtained one. Your YP is already obtained, therefore the final output will be y is equal to C1 is a power of minus 3x plus C2 is a power of minus 2x, which actually is a particular solution, and I mean the homogeneous solution, and the particular solution 1 over 2x squared minus 5 over 6x plus 19 over 36. So the general solution is going to be this one, which is actually the combination of y homogeneous and y particular. I hope you have understood this in a better way. Thank you.